Hello, in this video I will show the basics of 5-axis milling in SprutCAM. So right now you can see simple 5-axis machine. This machine has the rotary table and B-axis that rotates the spindle. This is the modern machine. So if you have the modern machine that support tool central point management mode, be sure that you have this tick enabled. A moment. Control parameters, rotary transformation. TCPM mode is available. This tick must be enabled if it is available on your machine. So, how to use indexed 5-axis milling? For example, I have this workpiece and I would like to machine this face. I select this face and create roughing auto line. Automatically SprutCAM calculates the position for B and C axis that will be used while indexed machining. If I click run, toolpath will be ready. Go to simulation and I start the simulation. That's good. Well, let's have a look on toolpath. I select this postprocessor FANUC 30. It is included in the standard package of SprutCAM. And for the first operation, we can see first tool, origin, and this line is very interesting, G68.2. This command rotates the local coordinate system, where we can find it in CL data. If I go to simulation, open header, open approach, we can see this one. Start, B and C rotates, after that X, Y, after that Z, and enable the origin. Origin will rotate this axis. Look at this point, and if I place this block, it is rotated now. Well, next step, and after that is machining. Well, it's indexed machining. So to get this command that will be transformed by postprocessor to G68, you have to enable this parameter, local coordinate system. If I disable it off and recalculate the toolpath, they have the same toolpath, but I will look on CL data. There is no origin command here, and machining will be performed in this coordinate system. So there is no circles movement and so on. Well, next step. So if your machine supported, you have to enable set to local coordinate system to auto. Well, next step. For example, I would like to make continuous 5-axis milling. For example, this chamfer. I create finishing 5-axis contouring and define the cylindrical mill, this, and strategy set to flank. Okay, and after that add the job assignment to my operation. Remove this for this job assignment. Define the... Okay, that's good. Well, calculate the tool pass. If we will look at our tool pass, something wrong. Recalculate everything. Start. Too fast. Repeat. This one, and this one. Okay. After that, go away and go to tool change point. Well, what is important in continuous 5-axis milling? It's necessary to enable tool center point management. It must be enabled, and local coordinate system for this mode must be disabled. You have to make it manually. What it gives? I calculate the second operation, and let's have a look on CL data. There is this command, interpolation 5-axis on, and after the machining it will be disabled. So interpolation off. Well, how it looks in the program? I define the same post process. It's the first operation and the second second operation. It uses this tool center point management G43.4. Well, thank you for your attention. Bye.